Hi, my name is Maria Grima, and I work for Shinnecock Bay Restoration Program. I graduated from Stony Brook University with a BA in Environmental Studies and minors in Marine and Geospatial Science. What I love about my job is that I get to work in the field. Sometimes it's too hot and sometimes it's too cold, but I take that to a regular desk job any day. Shinnecock Bay Restoration Program, or SHRP for short, was founded in 2012 in response to the deteriorating water quality of Shinnecock Bay. Our mission is to use science, outreach, and partnerships to restore this important estuarine habitat. One of the ways we monitor biodiversity in the bay is by conducting benthic trawls every 2 weeks from the end of April to the end of October. For those of you who don't know, a trawl is when you deploy a net from the back of a fishing boat, like so, run the boat very slowly, and pick the net back up after a set amount of time. We do this at 12 sites across the bay and record what we find. Once the net is on the boat, we dump the catch into a black sorting tray. Immediately after, SHRP volunteers work quickly to make sure all fish are placed into a bucket of water to await identification and measurement. We use rulers to measure a fish's total length and fork length if they have one. Fork length is the length from their nose to the spot where their tail naturally splits into two, if it does. As conservationists, we strive to have as little negative impact as possible and do our best to make sure all of the fish return to the water alive and safe. Crabs can survive for long periods of time outside the water, so we process them last. They're usually handled with gloves and stored in those bright orange bins. We measure the length of a crab's carapace or main segment using calipers and take down their sex and whether or not they are gravid or carrying eggs. We also weigh and identify buckets of algae. We catch all kinds of critters on the trawls: porgy, eels, forage fish, burrfish, blue crabs, pufferfish, seahorse, shrimp, and squid, just to name a few. Another way we monitor the bay is through BRUVs, or baited remote underwater videos. You're looking at a BRUV right now. They're not super high-tech, they're kind of just cinder blocks fastened with bait bags and a camera. And of course they're standardized. We throw them over the side of the boat at different locations and let them run for about an hour. The reason we use these is that we can account for certain species that will outsmart our trawl nets, like smooth dogfish. The videos we get are pretty cool, and we can turn these sightings into maps like the one featured now. With all the monitoring we've done, we've determined that one of the ways we can help the bay is by replanting eelgrass. Eelgrass is an important habitat for fish and can act as a nursery ground for babies to grow into adults. Our main planting event is in the summer. First, we scuba and snorkel around the bay to find healthy patches of eelgrass, and once we do, we collect thousands of their reproductive shoots. After bagging them in bushels of 100, we attach the bags to cinder blocks and floaties and dump them in the areas that could use a little help. The floaty keeps the bag up, and the tidal action releases seeds little by little over the desired area. See all that shell? We collect it from local restaurants and oyster festivals and use it to build oyster reefs in the bay. We've built 2 and plan to build at least 2 more.
Here at the drying site, where we take all the oyster shell and clam shell and whatever shell that we've collected from our shell recycling program and dry them out for 6 months. This is necessary so that we can sanitize everything and make sure that, no diseases or invasive species are communicated to our oyster reef.
Again, this is not something super high-tech, but it's highly effective and it's the standard practice. We kind of just took a section of our university's parking lot and have been using that to dry the shell. I think it's really cool because it just shows that you can have a high impact without being super technical or requiring a large budget. After the 6-month drying period, they look something like this. And, at that point, we take them to our marine lab and put them in mesh bags and grow spat on them. Spat are larval oysters. Once those oysters are big enough, we place them into the oyster reef. We actually monitored our reef a couple of days ago, and it's doing really well. The oysters started solidifying the walls, which is exactly what we wanted. And there's a lot of new species and higher abundances in the bay. So we're really happy about that. But anyway, I hope that you got a taste for what being a marine scientist is like, and thank you for watching. Bye.